Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of several of our HSM operations on this electronic box. Now, if we were to go into our first operation, we'll be doing first the HSR operation of HM roughing to rough out the material that's inside. Our tool itself is a 30 millimeter end mill, which is relatively large, as you can see over here, and it's also sticking outside of our holder only 20 millimeters, rather a short distance. Now, in this particular case, we have a deep pocket. So what would normally happen in this particular case is that the holder runs the risk of hitting the material as it goes further down into the part. But for that, we're using the option over here of holder clearance. This will automatically keep the holder away from the stock so that you can always work safely no matter how deep you're going. If we take a look at the passes itself, we have a wall offset of 0.5 millimeters and we'll be stepping down every 10 millimeters. Also in this case, we'll be using the step over type of cavity. Since this is a cavity, this option is made specifically for working in cavities. Now let's take a look at our simulation. If we take a look at a simulation using Solid Verify, we'll first start off going into the part, and it has its first step down of 10 millimeters. Now when it goes to its next level, you'll notice the following. We'll have actually, and I'll stop this right now, we have a larger step over here. The reason for that, because there's a protection of the holder towards the stock, so in order that the holder will not touch the stock, it gives you a larger step in. Let's take a side view at the moment, and you'll see the holder is actually inside of the part already, but because of that larger step over, we can go further deep into the part itself. And as you see, when we go down, we'll go down all the way to the bottom with larger step overs, allowing the holder to go as far as possible into the part itself. Now, in the next operation, we again will be doing a roughing operation, but this time we'll be using rest roughing. Now, if we go into our tool, this time we'll be using a smaller end mill, a 16 millimeter end mill, and it'll be outside the holder by 80 millimeters. So the entire end mill can actually go towards the bottom of the part. If we go into our passes, you'll see that we'll still have the offset of 0.5 millimeters, but we'll be taking smaller steps, every 5 millimeters instead of every 10 millimeters we did last time. If we take a look now at our simulation, you'll see that the end mill will be working only on those steps and clearing off all this excess materials from the outside over here as well. And since this can go all the way down to the bottom, it'll go down to the bottom and along the wall. And besides that, there were two pockets on the bottom which the previous end mill was not able to work on. This end mill will clear those areas as well. Now, the rest of the operation that we have here will all be finishing operations to finish off the walls of the part. And we've broken this up into several different areas. For our first operation, I'd only like to work on this area over here. So for that, we've used the option of constant Z machining. The end mill I'll be using in this particular case will be a 12 millimeter bullnose tool with a 0.5 millimeter radius on the tip. If I were to go into the passes, you'll note that I'll be stepping down every 0.15 millimeters, and I've also limited my down step to a total of -5 to only go down to this level over here. If we were to take a look at the simulation, you'll see that the tool works around the part and it will go down only up until that level as we see over here. In our next operation, we'll be doing the exact same type of operation, using the exact same end mill as well, but this time in the passes, we'll be going between a z-top of minus 62 up until the bottom of minus 72. In other words, we'll be working between this surface and this surface. Again, we'll be using a step down of 0.15 millimeters. And if we take a quick look at our simulation, you'll see that the tool will only work in those areas as shown over here. Now, in our next operation, I like to finish the floors as shown over here. So for that, I've used the option of HSM of horizontal machining. I'll be using the same end mill I used in my previous operation, and if we take a look at our passes, I've limited the operation to work only between 66 and 72. So if we take a look at our simulation, you'll see that the horizontal cuts will only be working on this floor and in those two pocketed areas. Now, in our last operation, I'd like to work on these tapered walls. These tapered walls are at 12 degrees. If I have to go into this operation, we'll be using the option of constant Z machining, and the end mill that we'll be using will be a tapered mill. HSM recognizes the tapered mill as well. The tapered mill will have an angle of 12 degrees, just like the taper of the wall itself. If we go into our passes, since we're working with a tapered tool that can cover a large area of the wall itself, so we can use a larger step down of every 10 millimeters. Let's take a look at the simulation, and you see that the tapered mill will be working on that wall and then stepping down 10 millimeters until it gets to the very bottom of the part, completing that entire area. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for our Professor tab. Take care and have a nice day.